Recording. Okay. So that even if they join late, I can do.
Auntie,
Ah,
auntie, from next class, we'll fix one timing, auntie. What time we have to fix?
this timings only. It is suitable for you all, no?
Fine for me, auntie.
That's what. Yes. We'll have at this time only. Anyway, I'm recording, no? So if one
Auntie, is everyone okay with this timing?
you are okay with these timings, no?
I am asking everyone, auntie. I am okay with this timing.
You are okay. I have put it in the group also. If they have any problem, Bharadwaj, no issue. I will teach them individually. If they have not understood anything, they can call me at their convenient time. I will teach them individually. I'll put it in the group. I'll repeat, no problem. Because I know you are all from different schools and different timings. It's difficult for you to. Just find out Rishi and Abhik is joining.
Auntie, Abhik will come in 5 minutes, seems.
Yeah, he'll come in 5 minutes. Okay. Okay, we'll start with the problems. Did we? Which one? Which was the last problem we did? Did we do that 20 cc of calcium chloride and 60 cc of 0.2 m calcium chloride are mixed? That was the last one.
1 minute, auntie. I'll just take my notebook.
Get the calculator also. Just tell me which was the last problem. I'll mark it from next.
Is 20 cc of 1 molar calcium
Okay.
chloride.
That's what I said. Okay, 20 cc. Next you write down. Calculate.
Auntie, 1 minute, auntie.
You get it. Please redo all the problems what we have done it in solutions. Definitely you will have so much knowledge. You can do book back easily. Even then one problem is very tough in book back. Very tough. I don't know why they gave that. But anyway, I will work out that at the end. I found it very tough actually. Shall I start, Bharadwaj?
Yes, auntie.
Okay. Calculate the number of moles of methanol. Calculate the number of moles of methanol in 5 liter. Calculate the number of moles of methanol in 5 liter of its 2 molar solution. Its 2 molar solution. You have to calculate the number of moles of methanol. What is the number of moles of methanol in 5 liter of its 2 molar solution. Given if the density of the solution is 0.981 gram per cc. 0.981 gram per cc. Molar mass of methanol 32 gram per mole. Molar mass of methanol 32 gram per mole.
Auntie, can you repeat from gigawatt density?
I will repeat. Calculate the number of moles of methanol in 5 liter of its 2 molar solution if the density of the solution is 0.981 gram per cc. Molar mass of methanol 32 gram per mole. 32 gram per mole. How will you do this? How will you do this? See, what do you mean by 2 molar methanol solution? Split it. What do you mean by 2 molar methanol solution? That means 2 moles of methanol in 1000 grams of water. In 1000 grams of water. What do you mean by 2 moles? 1 mole is 32 grams. 2 moles will be 64 grams of methanol in 1000 grams of water. That means when I say 2 molar solution, it is 64 plus 1000. So 1064 grams of solution. So then volume of that will be equal to mass by density. Find out the volume. Put it in liters. So many liters contains 2 moles. So 5 liter contains how many moles? Do it like that. First, 2 moles of methanol in 1000 grams of water. 2 moles means 64 grams. So 64 grams of methanol plus 1000 grams of water. So total volume will be equal to volume of solution. 1064 grams. So volume, if you convert this to volume, you get divide by the density, you will get it in volume. Why you need it in volume? Because they have asked in volume. They have asked in 5 liter, 5000 cc. Okay. So you can put it in cc or liter, anything. So many liters contains 2 moles. 5 liter will contain how much? Do it.
Auntie, can you send me a picture of the board?
Oh, okay. It is not clear.
No, Auntie, it's very
No,
hard to
Auntie.
read.
Auntie, can you tell the question once again, Auntie? I think I missed something.
Calculate the number of moles of methanol in 5 liter of its 2 molar solution. If the density of the solution is 0.981 gram per cc. Molar mass 32. Bharadwaj, Rishi is asking, can we make it at 5:30?
I am okay, auntie.
5:30 to 7 it will be. Is
Yes,
it
auntie.
okay?
I'm fine.
Okay. I'll put it in the group also. We'll have it at 5:30. Rishi can join. What is the answer you're getting?
Auntie, we are getting 1084.6.
1084. 84.6 or
Yes, Auntie.
0.0846 liter will contain 2 moles. 5 liter will contain how much? Do it fast. Over. What is the answer?
And is it 5.423?
No. No. 1.085 liter will contain 2 moles. 5 liter will contain how much?
And it should be into 5, right?
2 into 5 by 1.084. Solutions, Avik. We just finished one problem. Just wait. Just leave 4-5 lines. Then you start from the next problem. Only one. We are doing the first one.
And is it 0.43?
Why are you making that mistake? 5 into 2 by 1.085. 10 by
Oh, okay, Auntie.
1.5. You will get around 9 point something. Bharadwaj?
Auntie, can we use calculator,
9.21.
auntie?
9.2 moles. Okay. Write down next one. Very important because there is only one problem of this type and both in the book also everywhere they have given only this. So I will do that. A sample of drinking water was found to be severely contaminated with chloroform. What is the formula?
CCl3.
CHCl3. Contaminated with chloroform, supposed to be a carcinogen. Cancer causing chemical.
It's supposed to
Level
be.
of contamination was
It's supposed to be.
a carcinogen. CARCINOGEN.
Auntie, what does that mean, auntie?
Cancer causing chemical. It causes carcinogens means they cause cancer. The level of contamination was 15 ppm by mass. 15 ppm by mass. Parts per million. 15.
Auntie, 15 or 50?
15 ppm. That itself is very high. 15 ppm. First one. Express this in percent by mass. First one. Express this in percent by mass. 2. Determine the molality of determine the molality of CHCl3 in the sample. Determine the molality of CHCl3 in the sample. How will you do this? You have to raise your thinking level. How to do the second part? Do it. Do it. Very good, Abhik. Abhik is working hard, very hard, very good. First part is very simple. Percent by mass means, see 15 ppm by mass means 15 grams in 10 to the power of 6 grams of solution. Percent by mass means for 100 how much? 10 to the power of 6 contains 15 grams. For 100, anything for 100 is percent. So it will be 15 into 10 to the power of minus 4. Second part, do it. Molality, do it.
And this will be 15 into 10 power 6 into 100.
Aha.
Ah.
10 to the power of 6 grams contains 15 grams. For 100, how much? Anything for 100 is percent by mass.
Okay, Andy. So 15 into 100 by 10 power 6.
Yes.
Okay.
15 into 100 by 10 to the power of 6. So it is 15 into 10 to the power of minus 4. Now do the molality one. What is molality? W into 1000. Tell me the answer, Abhik. M2 into W1. M2 into W1. But here remember, tell me Abhik, you typed something? He said something I didn't see. Okay, just a minute. Okay. So, but here, remember Bharadwaj, Krupa, Abhik, remember you are given the mass of the solution. Here you want mass of solute and solvent. How will you get it? Mass of solvent, how will you get? Mass of solvent, how will you get? So easy, why are you not answering? Correct. So mass of solvent will be 1, 2, 3, 4, 5, 6. Okay. Minus 15. So it will be 9, 9, 9, 9, 9. So it will be 99999 495 grams. So 15 into 1000 by, find out the molecular mass of chloroform. Find out the molecular mass of chloroform. Carbon 12, 135.5 into 3.
One not 6.5 NT.
Yes. 119.5 into 99995 grams. Find out this. 15 into 1000 by 119.5 into 99995 grams. Got it, Krupa?
Andy, I do not understand that mass of solvent. Andy.
Okay. See, mass of solution is 10 to the power of 6 grams. 1 million. Correct?
Yes, aunty.
That is mass of solution, because when I say it is 15 ppm by mass, it is mass of the solution. Okay, so I know the mass of solute 15 grams. I know mass of the solution. So subtract, I will get the mass of the solvent.
Okay, aunty.
Now just the mathematical part. Just calculate and tell me the answer. What is the answer?
1.25 into 10 to the power minus 4.
Very good. 1.25 into 10 to the power of minus 4 molar. Molar. Okay. Next, write down. Next problem. A solution obtained by mixing, same problem is there in the textbook, similar problem rather. By mixing 200 grams of 30% 200 grams of 30% and 300 grams of 40% solution by mass. Calculate, I repeat, a solution obtained by mixing 200 grams of 30% and 300 gram of 40% solution by mass. Calculate the mass percentage of the resulting solution. Calculate the mass percentage of the, like this only problems will be there in solution. Okay. Now, how will you do this? Who will tell me how to do this?
And you have to find mass of solute, aunty, first.
Correct. Mass of solute in both the solutions. And then find out for 100. Correct?
Yes, aunty.
Do it. Krupa, understood? You didn't understand?
Yes, aunty.
Understood?
Yes, aunty.
Okay, do it. Let me see. Abik? Do it fast. We can work on more problems. Understood. Very good. Do it and tell me. Let me see who will give me the correct answer. I'll give you 2 minutes. What is the answer?
And we have to find the mass percentage of the solute.
Yes, mass percentage of the solute. This is all asked in the MCQs also. 1 mark.
And is it 24%?
No. Check it up. Bharadwaj?
Aunty, can you repeat the question?
Okay, I repeat the question. A solution obtained by mixing 200 grams of 30%, 30, and 300 grams of 40% solution by mass. Calculate the mass percentage of the resulting solution by mixing both. Abik?
And almost done, Auntie. 1 minute.
Done. Okay.
And is it 36%?
Very good. Right. You had made, I think, small mistake. 36. Very good. Bharadwaj, you got it? Both of them got. Krupa, Abik got.
Got it, Auntie.
Got it. So, how will you do? 30 grams in 100. So, for 200 grams, it will be 60 grams. Here, this will be 120 grams. So, 180 grams solute and 500 grams of solvent. For 100, how much? 500 grams will contain 180, 100 how much? Very good. Next, now we finished all that molarity problems we have finished. Now we will start with Henry's law. Okay, right on. At what partial pressure? At what partial pressure oxygen will have a solubility of? At what partial pressure oxygen will have a solubility of 0.05 gram per liter, 0.05 gram per liter in water at 293 Kelvin. At 293 Kelvin. KH for oxygen in water. KH for oxygen in water at 293 Kelvin. KH for oxygen in water at 293 Kelvin is 34.86 bar. 34.86 bar. Sorry, 34.86 kilobar. Kilobar. Do it. Assume the density of the solution to be same as that of the solvent. Assume density of the solution to be same as that of the solvent. Do it. So, how will you do? Partial pressure of oxygen is equal to KH into X of oxygen. Henry's law. KH they have given. You have to find out the mole fraction. What is mole fraction is equal to N of oxygen by N of oxygen plus N of water. N of water. So, 0.05 gram per liter means 0.05 gram of oxygen in 1000 grams of water. 0.05 grams of oxygen in 1000 grams of water. So, find out N of oxygen, N of water and find out mole fraction and then find out partial pressure. Do it.
Auntie, here we have to find only partial pressure, no, Auntie. Then we can KH into X.
X you have to find out, no, mole fraction.
Yes, Auntie.
The mole fraction, number of moles of oxygen by number of moles of oxygen plus
Okay.
water.
Yes, Auntie.
Find out both and then find out mole fraction. Actually, it is in 1 liter of the solution, but 0.05 add or subtract, it doesn't change the value. So you can take it as 1000 grams of water. Keep it in kilobar only, no problem. Correct. Correct. Then find out partial pressure. What is the answer?
And is it 0.98?
Huh?
0.98.
Very good. 0.98 kilobar. Got it, Krupa, Abik?
Yes, Aunty.
Okay. Okay, I'll just give you an easier one, then we'll do the tougher one. The mole fraction of helium in a saturated solution, the mole fraction of helium in a saturated solution at 20 degrees centigrade is 1.2 into 10 to the power of minus 6. The mole fraction of helium in a saturated solution at 20 degree centigrade is 1.2 into 10 to the power of minus 6. Find the pressure of helium. Find the pressure of helium above the solution. Above the solution. Given KH 144.97 kilobar. Given KH 144.97 kilobar.
Andy, can you repeat the question?
The mole fraction of helium in a saturated solution at 20 degrees centigrade is 1.2 into 10 to the power of minus 6. Find the...
Andy, 1 point?
Yeah.
1.2
into 10 to the power of minus 6. Find the pressure of helium above the solution. Given KH at 20 degrees centigrade is 144.97 kilobar. Direct question. I just wanted to give one simple one. What is the answer? Just one step. Correct. Correct. 0.174 bar.
Yes, Aunty.
Got it, Krupa? Just multiplication.
Yes, Aunty.
Now you do this. Air contains oxygen and nitrogen in the ratio 1:4. Air contains oxygen and nitrogen in the ratio 1:4. Calculate the ratio of solubilities. Calculate the ratio of solubilities in terms of mole fractions of O2 and N2, in terms of mole fractions of O2 and N2 dissolved in water at atmospheric pressure and room temperature. At atmospheric pressure and room temperature, at which Henry's constant for O2 and N2 are 3.3 into 10 to the power of 7 torr and 6.6 into 10 to the power of 7 torr. Even this can be asked for 1 mark. You have to find out the ratio of the solubilities. How will you do this? What is the answer? Who will tell me how to do this? You know how to do this? Or shall I explain?
Aunty, can you explain, Aunty?
Okay. See, the air contains oxygen and nitrogen in the ratio 1:4. That means 4 plus 1, 5. So, partial pressure of oxygen will be 1/5 and partial pressure of nitrogen will be 4/5. Okay. So, then what you do? You have to find out x of oxygen is to x of nitrogen. So, write down two equations. Partial pressure of oxygen is equal to kH of oxygen into x of oxygen. Divide by partial pressure of nitrogen is equal to kH of nitrogen into x of nitrogen. So, substitute now. Partial pressure of oxygen is 1/5. So, what is 1/5? 0.2. Okay, that equal to 3.3 into 10 to the power of 7 into x of oxygen. What is 4/5? 0.8. equal to 6.6 into 10 to the power of 7 into x of nitrogen. So this will be 2 this will be 4 So 1/4 is equal to x of oxygen by 2 into x of nitrogen. So if you cancel this, it will be 2. So 1/2 is equal to x of oxygen by x of nitrogen. So this will be 1:2. X of oxygen is to x of nitrogen is equal to 1:2. You don't need calculator for this. You can just do it like that.
Auntie, can you send a picture of the board?
Yeah. Absent. Over.
Yes, Auntie.
Okay. Next. Next is also very nice problem. You do it, think and do it. It's based on Henry's law only. The KH for oxygen, dissolved in water the KH for oxygen, what is this? Sorry, there was some. The KH for oxygen dissolved in water is 4.34 into 10 to the power of 4 atmosphere. 4.34 into 10 to the power of 4 atmosphere at 25 degrees centigrade. If the partial pressure of oxygen in air is 0.2 atmosphere, if the partial pressure of oxygen in air is 0.2 atmosphere, calculate the concentration in moles per liter. Calculate the concentration in moles per liter of dissolved oxygen in water of dissolved oxygen in water in equilibrium with air at 25 degrees centigrade. At 25 degrees centigrade. See, KH is given, partial pressure is given, okay? You have to calculate the concentration in moles per liter of dissolved oxygen. That is, first find out KH is given, partial pressure is given, find out X, mole fraction. From mole fraction, you have to calculate number of moles of oxygen per liter in 1000 grams of water.
And what did you tell at the last NT after finding mole fraction?
Yeah. After finding mole fraction, what is mole fraction is equal to
partial pressure by Henry's constant.
By number of moles of oxygen plus water. They're asking you to find out the number of moles of oxygen. The number of moles of oxygen. Here, if you want, you can calculate with the number of moles of oxygen in the denominator, or you can neglect it and just take number of moles of water in the denominator and do it. Both are okay.
Auntie, here we have partial pressure and Henry's constant, auntie. So we can divide those both, auntie, using a formula.
Yeah, that's what. First find out X. Partial pressure of oxygen by KH. Find out X. Now you know X per liter.
Oh, okay.
So you can calculate number of moles of water. Find out number of moles of
oxygen.
Okay,
Auntie, you are telling the second step. Okay.
Ah, yes. Do it. Do it and tell me.
The mole fraction is 4.65, auntie.
4.6 into 10 to the power?
4.6 into 10 power 3, auntie.
No. No. Check it up. 0.2 by 4.3.
4.6 into 10 to the power minus 6.
Ah, minus 6. Very good. 4.6 it correct. Abhik also got. Bharadwaj, check the power. 4.6 into 10 to the power of minus 6.
Yes, auntie. Small error.
Now find out N of oxygen. N of water you find out. It is 1 liter. So 1000 by 18. Same. 55.55. So N of oxygen will be equal to X of oxygen into N of water. You can take it directly. It becomes easier. Or you can take that also and do it. No problem. Find out. Even if you take that N of oxygen in the denominator, it will be very, very small. So it will be X by X plus 55.55. Then take X to this side, subtract and do it. You can do that. But even then it will be very small difference will be there. So you can do it directly. Because oxygen dissolves in water to a very small extent. So you can neglect number of moles of oxygen in the denominator. Understood? What is the answer? Final answer?
Andy, can you hear?
Yeah.
Andy, is it 255.5 into 10 power 6?
10 to the power of
6, Andy.
6. Check it up.
Andy, value is correct?
A value is correct. Power you check. Yeah, 2.55 into 10 to the power. Hey, check the power, man. A big
It should be -4, right?
-4. Very good. 2.55 into 10 to the power of -4. Bharadwaj, it is minus, man. Check it up. Be careful with the power.
Andy, can you tell how, Andy?
See, so just multiply these two, man. 4.6 into 55.55.
Yes, Andy, if you multiply that, I'm getting 255.5, Andy.
0.5. Correct? Into
Yes,
10 to
Andy.
the power of -6.
Yes.
So, if you
Ah,
shift 2 point this side,
then minus. Oh, Andy, did I say 10 power 6?
you
Oh,
say
okay,
10 to
okay,
the power
sorry,
of
Andy. Minus 6.
-6.
Yes, yes, Andy. Maybe I told 10 power 6. Yes,
You
and I
are
got it.
dividing by 100. So, if to multiply by 100, this becomes -4.
Yes, and I told in 10 power minus 6.
That's what. This is about Henry's law. Now we will do on Raoult's law problems. Very interesting. Raoult's law problem. You will like it. Okay. Two liquids X and Y. Two liquids X and Y on mixing for an ideal solution. Two liquids X and Y on mixing for an ideal solution. Oh, that is little difficult, but it's okay. Do it. At 30 degrees centigrade, at 30 degrees centigrade, the vapor pressure of the solution, just write Vp, you will understand. The vapor pressure of the solution, containing 3 moles of X, containing 3 moles of X and 1 mole of Y, containing 3 moles of X and 1 mole of Y is 550 millimeters of mercury. 550 millimeters of mercury. But when 4 moles of X and 1 mole of Y are mixed, when 4 moles of X and 1 mole of Y are mixed, the vapor pressure of the solution formed, the Vp of the solution formed is 560 millimeters of mercury. 550 millimeters of mercury. What would be the vapor pressure of pure X and Y? What would be the vapor pressure of pure X and pure Y at this temperature? At this temperature. Oh, I should have done this problem first. Will you leave some gap and write down the next problem? We'll do this next.
Okay.
Okay, just leave and 7-8 lines. It needs 7-8 lines. Write down this problem, because I will do like this first and then that. I have marked, actually I made a mistake. The mole fraction of ethyl alcohol, the mole fraction of ethyl alcohol in its solution with methyl alcohol, in its solution with methyl alcohol is 0.8. The mole fraction of ethyl alcohol in its solution with methyl alcohol is 0.8. The vapor pressure of ethyl alcohol, the vapor pressure of ethyl alcohol at the same temperature of the solution, at the same temperature of the solution is 40 millimeters of mercury, is 40 millimeters of mercury, 40. What is its vapor solution? What is its vapor pressure? What is its vapor pressure in solution? In solution, if the solution is ideal. If the solution is ideal. Direct problem. So, partial pressure is equal to P naught into X. What did we do? We wrote P1 is equal to P1 naught into X1. Okay. So, this will be partial pressure is equal to vapor pressure of the pure solvent into its mole fraction. So, this will be just equal to 40 into 0.8. That will be 32, 320, 32 millimeters of. So, Raoult's law for only one solvent. First, we have to start with this problem. You know, no, PA is equal to P naught A XA. PB is equal to P naught B XB. What does the Raoult's law state? PA plus PB is equal to P naught A XA plus P naught B XB. P total. This is nothing but P total. Okay. So, for 1 it is like this. If you have 2 for an ideal solution, it will be like that. Okay. It is 32 millimeters of mercury. Just multiplying. Remember now. Vapor pressure of the solution is equal to vapor pressure of the pure solvent into its mole fraction. That's all. Now, do this problem now. What I dictated. X and Y problem. Do it. So, I will tell you now. 3 moles plus 1 mole. That means out of 4 moles, total 4 moles. So, partial pressure of X is equal to 3 by 4. Partial pressure of X is X mole fraction, sorry. Not partial. Mole fraction of X is equal to 3 by 4. Mole fraction of Y is equal to 1 by 4. . So it is not 1 by 4 x y. So this will be 0.75 x. This will be 0.25 y. This is first case. Second case, 4 plus 1, 5. Out of 5 moles, partial pressure of x is equal to 4 by 5. X, partial pressure of y is equal to 1 by 5 y. So this will be 0.8 x, 0.2 y. So you have two equations now. Total for the first is 550 is equal to 0.75 x,
Auntie,
0.25 y.
Auntie, you're doing the last question, Auntie. You told to
Last
leave
question.
space.
Yes.
No, Auntie, you told leave space. That question you're doing.
That question. Yes. That question. 560 is equal to 0.8x plus 0.2y. Now solve for x and y. Sorry, you write it as.
Auntie, can you send a picture?
1 minute, 1 minute. One minute. Okay. So you have one equation, two equation. Wait. Absent. So you will get two equations, two separate equations, because on mixing two different in two different proportions, total will change. Okay. So you will have two equations. Solve for P naught x and P naught y. They have asked for the pure solvents. So to make it equal, how will you do this? How will you do any algebraic equation like this? You will make one of them equal and subtract, isn't it? So here what you do here is multiply this equation by 0.2 and multiply this equation by 0.25. So that you can cancel off these two. Okay. So how will you do this now? If you have the calculator, it is easy. Just wait, I'll get my calculator. Otherwise, you will take more time to do. I will use the calculator and do it. It will be easier for me. $110 equal to 0.15 plus no man, there is something wrong. Wait. What I have done, I can make it equal. I multiply this by 5 and this by 4. Why I have to do like that? I can do like this also. Wait. Oh, if you keep it in fractions, it will be like that. That's 110, 140. Do it, man. Simplify. I will do it on the board and see. Correct, man. What we did was correct. No problem. You do it. So what you do now? Multiply this by 0.2 and this by 0.25. So this will be 110 equal to 0.15 P naught X plus 0.5 P naught Y. You put this up, second equation up, because that is more. So this will be 0.2 P naught X plus 0.5 P naught Y. So if you subtract, this gets cancelled. So this will be 30 equal to 0.05 P naught X. So P naught X is equal to 30 by 0.05. That equal to 600. Once you get one, it is easier to find the other. You can take any one of the equations and do the other. Do it. Just simplify the equations. You will get it. You will get the answers. Yes, pa, I'll just take it. Just solving the equation, that's all. Over? Did you copy?
Only 1 minute, Auntie.
Do it. Excellent. So this will be 1 minus 6. You can take the fraction and do. Then you will be multiplying by 4 and 5 because in this denominator is 5 and in this denominator is 4. So you can multiply by 4 and 5 and do it. But if you take divide and take it also fine. You just make it equal, that's all. One of them equal. Over? Copied, kids?
Yes, Auntie.
Okay, write down next one. There are so many very interesting problems on this. We'll do as much as possible. Then we'll do 2-3 more and then we'll start with the RLVP. Ethylene dibromide. Next problem. Ethylene dibromide. That is a gem dihalide. On the same carbon atom, you will have 2 bromine. Ethylene dibromide and 1,2-dibromopropane. Ethylene dibromide and 1,2-dibromopropane form a series of ideal solutions. Form a series of ideal solutions. Form a series of ideal solutions over the whole range of composition. Over the whole range of composition. At 85 degrees centigrade, at at 85 degrees centigrade, the vapor pressures of these two liquids are at 85 degrees centigrade. The vapor pressures of these two liquids are 173 and 127. 173 and 127 torr respectively. 173 and 127 torr respectively. What would be the mole fraction of ethylene dibromide tar, not tark, tar, pressure, TOR, tar. What would be the mole fraction of ethylene dibromide in a solution? What would be the mole fraction of ethylene dibromide in a solution at 85 degrees centigrade, at the same temperature, 85 degrees centigrade, equilibrated with 1:1 molar mixture of 1:1 molar mixture in the vapor. Read the problem again and tell me how to solve this.
Auntie, can you tell the two liquids name, Auntie?
Ethylene dibromide and 1,2-dibromopropane. 1,2-dibromopropane. Ethylene dibromide and 1,2-dibromopropane. How will you do this? Who will tell me how to do this?
Auntie, 1 minute, Auntie. I'll just read the question again.
You read the question again, then tell me. You know how to do all this. Only thing is, we know the theory. We have to apply it. To the problems, we have to apply. We have learned all these.
Auntie, first we should find partial pressure of A and B, Auntie.
Partial
By
pressure of...
we should find by moles, Auntie. We should find the moles fraction first. Then with that we can find the partial pressure, Auntie.
Any other answer, Krupa, Abik? Any other answer? Can you think? I thought of the same way. Krupa?
No, Auntie.
No. See, I will explain this. You are mixing 1:1 molar mixture. 1:1 molar mixture. Can you think now? See, what I mean here is, see, when I say 1:1 molar mixture, P1 naught X1 will be equal to P2 naught X2. So, now, how will I have to find out the mole fraction? So, what I will say is, let the mole fraction of ethylene dibromide be X. So, when I say mole fraction of ethylene bromide, that is X1 is X, means what will be X2 equal to? Tell me now. See, if you have two liquids, mole fraction of one is X. What will be the mole fraction of the other? Okay. What is the total mole fraction of, even if you have a binary mixture, what is the sum of the mole fractions equal to? What is this, man? See, always I keep telling this from day one. Sum of the mole fraction is always equal to 1. Sum of the mole fractions of any number of components is always equal to 1, like your probability. So, for 1 if I take X, the other has to be 1 minus X. Other has to be 1 minus X. So, if the mole fraction of ethylene dibromide is X, 1,2-dibromopropane will be 1 minus X. Since you are mixing them in 1:1 molar mixture, so this equal to this means 173 into X is equal to 127 into 1 minus X. Because you are mixing in 1:1 molar mixture. Both are same. So find out X from this now. If you know X, you will know the other. Do it. Write down. So let the mole fraction of ethylene dibromide be X. Then the mole fraction of 1,2-dibromopropane will be 1 minus X. 1 minus X. Since they are in 1:1 molar mixture, this into X is equal to 173 into X is equal to 127 into 1 minus X. Krupa, shall I send the pic?
Yes, Abhi.
It's not very clear, ma. Wait, I'll send you a link. Why it is not? I didn't get it. Now it is clear. The previous one it's not clear. Find out X now. Both of them left. I think they have another class or anything like that. What is X equal to? 173X is equal to 127 minus 127X. So 173X minus 127 plus 127x is equal to 127. So this will be 0, 0, 300. 300x is equal to 127. So x is equal to 300 by 127.
0.42.
Huh?
0.42.
Yes, 0.42.
Auntie, can you hear me, auntie?
Yeah, why did you escape, man?
Auntie, no, auntie, my father by mistake switched off the Wi-Fi, auntie. So it went. Auntie, can you just send the answer, auntie?
1 minute, man, 1 minute. Point 423333, it is recurring. Please work out all the problems again. I have still more beautiful problems on Raoult's law. 2, 3 more. Then we'll start with RLVP. If I start with RLVP, it's easier. And this one, it's easier. Depression in freezing point and elevation in boiling point, then osmotic pressure. Then you will have combined problems. They'll give you freezing point, and some problems are there wherein you have to find out all the four. RLVP, boiling point, freezing point, osmotic pressure. All the very interesting
Auntie,
problems are there.
those will not come in 1 mark, no, auntie.
Huh?
Those will not come in 1 mark and all.
See, if you have the knowledge, then you can, whether they give it 1 mark or 2 marks, what does it matter? It's, you can do it.
Yes, auntie.
You should be thoroughly prepared. Solutions, any problem asked, only problems are asked in solutions actually, not theory questions at all. That is why I am doing more and more problems here. Problems is where you increase your real level. Just learning the theory, just answering those theory questions, nothing. You won't learn anything. Application is what you have to learn. That is where they test. I'll finish all the solutions. Then you see how much you can work it out. Work out more and more, more and more. Difficult once you work it out. You will learn well. Okay? I'll continue in the next class. Okay? Wednesday I will do the, what I was doing? Solid state I started, no? I'll continue with solid state.
Auntie, can you send the answers for last 2 questions alone, auntie?
I've sent it, no? In the pic
No, auntie,
also I've sent it.
you sent it like the board one, auntie. I'm selling the note.
Answer, huh?
Ah.
Shall I tell you the answer now itself? Because I may forget it later. Previous one.
And you know what? I want the steps also.
I have not done the steps and all, man. I know the answers.
Okay.
Krupa, if she has done, you send a pic, no, Krupa?
Yes, auntie.
She will send.
Okay, auntie.
Okay. I will upload this. And previous ones I will delete because my storage space is not there. It is getting filled. Okay. So I will just delete previous ones, like earlier ones. I need some space. Okay. Okay, pa. Bye. Bye.
Bye, auntie.
Have a good night.